Fire-dependent ecosystems are increasingly at risk of high-severity wildfires that threaten communities and multiple values at risk. Landscape-scale prescribed fire can be utilized to protect life, property, infrastructure, and ecosystem services in this era of increasing wildfire risk, as well as restoring fire-dependent ecosystems and improving wildlife habitat. Land managers are often tasked with increasing the scale of prescribed fire application, but could benefit from further direction on the development of multi-unit programmatic burn plans. When are multi-unit or programmatic plans appropriate? What are the important planning considerations? And what tools are available to assist with analysis and burn plan development? This training module focuses on prescribed fire planning across multiple scales, with an emphasis on multi-unit prescribed fire plans. The Interagency Prescribed Fire Planning and Implementation Procedures Guide, PMS 484, establishes national interagency standards for the planning and implementation of prescribed fire. The PMS 484 outlines the activities to develop single-unit, multi-unit, and programmatic plans where the intent is to ignite single or multiple units. Increased interest in scaling up the application of landscape-scale prescribed fire necessitates a review of the conditions, requirements, and tools available to improve efficiency and quality of burn plans. Interagency agreements, memorandums of understanding, or private landowner agreements that outline responsibilities are required to implement prescribed fire across multiple ownerships, but refer to specific agency direction. Depending on project-specific factors, a single unit, multiple unit, or programmatic burn plan may be appropriate for your project. All types of burn plans can be tiered to multiple NEPA decisions as long as the objectives are the same and design criteria can be implemented. If you're new to multiple unit or programmatic burn plans, they may be the right tool for you to increase the amount of fire you're able to get on the ground with just a little bit more time spent planning. While planning times may be longer, they may give you more flexibility when it comes to implementation. Multiple unit or programmatic burn plans usually share similarity in vegetation, fuels, and objectives among the subunits, and have been written at all complexity levels. Programmatic plans may include multiple units that can be ignited separately or concurrently. Each unit has site-specific information developed for the application plan elements, such as the description of prescribed fire area, ignition, holding, organization, and contingency resources. Longer duration plans should take potential changes in fuel and weather over the implementation period into account, but also should consider the weather during the holding and patrol phases of implementation. Sequencing requirements between different ignition units should also be addressed in multiple unit plans. Since programmatic plans usually apply to large areas, typically measured in the thousands of acres, some variation in vegetation type and therefore fuel model is likely across the landscape. If your objectives across these vegetation types are relatively similar or can be achieved under similar environmental conditions across vegetation types, your project may lend itself towards a multi-unit burn plan. Even if you need separate environmental or fire behavior prescriptions for different fuel models, unit sequencing requirements may address this issue in a multiple unit prescribed fire plan. Vegetation types that share similarity in fire behavior prescription, weather prescription, and seasonality are often good candidates for programmatic burn plans. Vegetation types with differing objectives that require specific prescriptions should have those objectives and prescriptions clearly identified for each. Separate prescriptions may be required for multiple fuel model conditions or for different phases of ignition. The foundation for landscape-scale prescribed fire planning is provided in Land and Resource Management Plans, General Management Plans, Fire Management Plans, and Project-Specific National Environmental Policy Act (NEPA) analysis. Objectives and constraints for prescribed fire projects are tiered from these documents and can drastically impact the ease of implementation. Therefore, incorporating the intent of large-scale burning into early phases of the NEPA process through clear planning and sound analysis can facilitate large-scale prescribed fire implementation. Burn plans can cross boundaries between planning documents if the objectives and constraints of all applicable planning documents can be met. Whatever type of burn plan you choose for your project, it must all be cohesively explained together in the complexity analysis. Remember to fully evaluate separate prescriptions, organizations, or seasons of the prescribed fire. For example, a smaller blackline organization would likely have lower prescriptive limits than ignition of the entire unit, which must be documented in the complexity analysis and carried through the prescription, organization, ignition, holding, and contingency elements of the burn plan. In some cases, separate complexity analyses may be necessary. For instance, if your low-intensity blackline operation can be overseen by an RxB2, but the main ignitions require an RxB1, this would still require different prescriptions, organizations, ignitions, holding, and contingency elements of the final plan that clearly reference which complexity analysis is valid for which phase of ignition. Finally, make sure your agency administrator understands this nuance from plan design throughout implementation. Fire behavior characteristics for all fuel models in the unit and within the maximum spotting distance of the unit or adjacent to the project boundaries must be considered. Multiple prescriptions for one burn plan are permissible, but must be supported with appropriate modeling. Multiple tools are available for fire behavior and effects modeling. Geospatial fire modeling systems, such as FlamMap and Farsight, are useful in large landscape-level prescribed fire planning. Some of these desktop applications have been incorporated into the Interagency Fuel Treatment Decision Support System, known as IFTDIS. IFTDIS is a fuel treatment planning system designed to house reference data, streamline mapping, and fire behavior modeling, and produce reports and products useful for all types of fuel treatment planning. Geospatial modeling, whether using the individual systems or IFTDIS, can assist in the assessment of fire movement across the landscape and potential problem areas. A good example would be using the minimum travel time model to help inform spread over 1 or 2 operational periods for a contingency or holding plan development. Spatial fire behavior outputs can show areas on a map that may cause problems, such as high flame lengths or high rates of spread, which may inform the best placement of burn unit boundaries. Consider using the skills of an LTAN or FBAN to develop prescriptions for long-duration or landscape-scale projects. LTANs can be used to conduct climatology analysis for the planned ignition time, assess landscape-scale fire behavior, potential fire movement towards areas of concern, and desired fire effects to assist with burn plan prescription elements. Geospatial modeling can assist with visualizing fire movement across the landscape and help identify potential problem areas. Contingency plans with Identified Management Action Points, MAPs, should be identified and addressed in the prescribed fire plan. MAPs can be temporal or spatial, but should focus on areas likely to cause problems. One of the biggest takeaways from many declared wildfire reviews is the fact that contingency resources are very often not explicitly defined and therefore are not sufficient to bring the project back into prescription. Use Fire Family Plus to evaluate historical climatology in relation to the project implementation window and burn prescription development. Fire Family Plus can be used to evaluate the proposed combination of weather prescription elements, such as temperature and relative humidity, and when these combinations typically occur for the project area. Fire Family Plus can be used to examine general wind directions and wind speeds relative to the area based on a selected weather station for the period of times of interest. Wind Ninja can be used to assess wind flow across complex terrain in the project area under the preferred or problem wind conditions and identify critical holding points. Using climate and climatology to examine potential longer-term impacts on fuels and potential fire behavior can help avoid negative outcomes. This can include indices such as the Energy Release Component, ERC, and 1,000-hour fuel moistures, and in Alaska, in the Lake States, Buildup Index, BUI, or Fire Weather Index, FWI. Using these indices and their interpretation are strengthened when the current season is compared to previous years to provide context. The Fire Behavior Field Reference Guide, FBRG, has a section on weather covering drought assessments and available products. Multiple unit plans may take the format of a primary plan with all burn plan elements that covers the full project area and also includes appendices for each separate ignition unit that provides a map, prescription, specific objectives and values at risk, ignition, holding, and contingency elements. For multiple unit plans, identify any special sequencing requirements. PMS 484 requires that each unit has site-specific information developed for applicable plan elements, such as ignition, holding, and contingency prior to technical review and approval. Lessons from the field for multi-unit plans suggest that problems can result from inefficient detail for specific subunits. Fire-dependent ecosystems are increasingly at risk of high-severity wildfires that threaten communities and multiple values at risk, and land managers are tasked with increasing the scale of prescribed fire treatments. While planning times may be longer for multi-unit or programmatic burn plans, they may offer more flexibility and efficiency when it comes time to implement. Incorporating the intent of large-scale burning into early phases of the NEPA process through clear planning and sound analysis can facilitate large-scale prescribed fire implementation. Multiple unit or programmatic burn plans usually share similarity in vegetation, fuels, and objectives among the subunits and have been written at all complexity levels. Plan preparers should take advantage of the multiple tools available for fire behavior and weather analysis in the development of large, landscape-scale burn plans.